Hello, children. This is Reshmi Pillai from Mount Carmel School, and I'm going to teach you today physics, chapter heat transfer for class 8th. Let's start. For studying heat transfer, let me first explain you about the difference between boiling and evaporation. In both boiling and evaporation, matter changes from liquid to gas, but the two processes are quite different. When the temperature of matter increases, the particles of the matter gain energy and move with a greater speed. In evaporation, the particles at the surface escape and form gas. So, the process of evaporation takes place at the surface. Thus, evaporation is a gradual vaporization of a liquid on the surface. Whereas, in boiling, it is a rapid vaporization of a liquid which only moves when it is heated to its boiling point. In evaporation, no bubbles are formed, whereas in boiling, bubbles are formed. Boiling occurs throughout the liquid, but evaporation occurs only at the surface. Evaporation occurs at all temperatures, whereas boiling occurs at definite temperature boiling point. For evaporation, energy is supplied by surroundings. For boiling, source of energy is needed. Boiling occurs rapidly, whereas evaporation occurs slowly. The motion of particles is fast in boiling, whereas in evaporation, few particles move slowly and few at a faster rate. I hope the difference is understood to you all. So let's now go to the topic thermal expansion. Almost all solids, liquids, and gases expand on heating. The increase in the size of the body when it is heated is known as thermal expansion. You can see the figure. Now there are three types of thermal expansion. Let's study that. First is your linear expansion. It is the increase in the length of a metal rod on heating. Second is your volume expansion or cubical expansion. It is the increase in the volume of block on heating. Third is the superficial expansion. It is the increase in the surface area of a metal sheet on heating. Now we'll study one by one. So let's start with linear expansion. Suppose L is the original length of the solid rod. You can see in the video, the figure is shown. And let L be a small increase in the length of a rod when its temperature was raised. Okay. When its temperature is raised by a small amount, that is T, thus it is found that the length was proportional to the increase in length, and the increase in length was proportional to the temperature which was raised. Therefore, the increase in length is proportional to the length and the increase in temperature. The next is volume expansion or cubical expansion. Suppose V is the original volume of a solid, and let V be the small increase in the volume of a solid when its temperature is raised by a small amount, that is T. Thus, it is found that the increase in volume is proportional to its original volume, and the increase in volume is proportional to the increase in temperature. Therefore, Increase in volume is proportional to the volume with its increase in temperature. Third is superficial expansion, the last type. Here you're going to suppose that S be the original surface area of a solid. Let S be the small increase in the area of a solid when its temperature is raised by a small amount T. Thus, it is found that the increase in surface area is proportional to its original surface area, and the increase in surface area is proportional to the increase in temperature. Therefore, you can say that the increase in surface area is directly proportional to the surface area with the increase in temperature. Now we are going to study thermal expansion of solids. Let's see this. When a substance is heated, it absorbs heat and starts expanding. That is, most of the metallic substance expand on heating. The gases expand most and solids expand least on heating. You know the reason, because of intermolecular spaces. Unlike liquid or gases, solid materials tend to keep their shape when undergoing thermal expansion. Thermal expansion generally decreases with the increasing bond energy that effects on the melting point of solids. Therefore, high melting point of materials have lower thermal expansion. Now we are going to perform an activity to observe thermal expansion in solids. So let's see the activity. An iron ring ball apparatus consists of a metallic ring and metallic ball. The outer diameter of a ball is equal to the internal diameter of the ring. Look into the figure. Initially, the ball was easily passing through the ring. Now, heat the ball strongly for few minutes. You will observe that ball does not pass through the ring. Why it is so? Because its diameter has increased. After some time, when the ball is cold, it again passes through the ring. Now what does this show? This shows that solid expands on heating and contracts on cooling. The different substances of identical dimensions expands by different amounts when heated through the same range of temperature. Now we are going to perform an activity to observe the expansion in different solids. So we are going to take an iron and a brass metallic strip. Now let's see this activity. Take a strip made of two metals called bimetallic, made up of brass and iron. This strip looks flat at ordinary temperature, that is room temperature. Keep the strip over the flame of a Bunsen burner for some time. Observe what happens. You will find that the strip bends due to heating, such that brass is on outer side and iron is on inner side of the curved end. It shows that the equal length of brass and iron was there, but different metals are heated with same time and same range of temperature. Still, it has been bent, yet has an unequal expansion, that is, brass expands more than iron. This forces the strip to bend towards the iron side. I hope it's clear. Practical application of thermal expansion of solids we are going to see. The first example is, while laying the railway tracks, some space is left between the joints of the railway lines. You might have observed this. This is done because during excess heat, the temperature rises. If the rails are fixed, tightly, leaving no space for expansion. What will happen? They will bend in summers and may cause derailment of trains. Hence, to avoid it, some space is left between the joints of railway lines. So now you are familiar with the reason. Second example is for the wooden wheels of Tongas, the iron rims are made of the same size as the wheels themselves. The rims are heated before fitting so that they expand and fit over the wheels. After fitting, cold water is poured over the rims. On cooling, they contract and grip the wheels firmly. The third example is in construction of bridges, some space is left to allow the expansion to take place during high temperature. Therefore, during the construction of a bridge, one end is fixed and the other end is mounted on a roller to accommodate the expansion or contraction during the change in temperature. Now let's see thermal expansion of liquids. Liquids also expand when they are heated. Let us see with the help of an activity. Take a test tube and fill it to the brim with the water. Take a rubber stopper and make a small hole in it. Put it on the mouth of the test tube. Put a small capillary tube on the hole of the cork. Water will rise in it. Now, heat test tube. You will notice that the water will rise further in the tube. This shows that liquid expands on heating. Example, thermometer. This is one of the application of the thermal expansion of liquid. Now, thermal expansion of gases. Expansion in gases is maximum than in solids or liquids. You can see in the figure the intermolecular spaces are greater in gas. On heating a gas, the molecules move far away from one another. Thus, the gas tends to increase its volume. Let's see the activity. Take an empty flask and fix a balloon to its neck. Heat the flask using a burner and observe the balloon. After some time, the balloon gets inflated. Now, leave the flask to cool down. The balloon will get deflated. Have you observed the difference? It shows that gases expand on heating. Hot air balloons. The interesting example of expansion of gases is hot air balloon. Hot air balloon, inside the balloon bag expands more quickly than the outside container. So, it stretches the bag so that it expands and displaces the colder air outside the bag. Scientist named Anders Celsius. He was a Swedish astronomer and he was a professor of astronomy at Uppsala University from 1730 to 1744, but traveled from 1732 to 35, visiting notable observatories in Germany, Italy, and France. He founded the Uppsala Astronomical Observatory in 1741 and in 1742. He proposed the Celsius temperature scale, which takes his name. So, how, from where Celsius came? Now you understood it. Celsius conducted many geographical measurements for the Swedish general map and was one of the earliest to note that much of Scandinavia is slowly rising above sea level. A continuous process which has been occurring since the melting of the ice from the latest ice age. However, he wrongly posed the notion that the water was evaporating. So, today's class, I hope it's interesting. Thank you, children.